All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be continuing. We're going to be we're going to be continuing where we left off yesterday because I'm still not done preparing this shopping list. The list is actually pretty small. Um, it's it's the fact that I need to do research on the items. Like I know what I want, but or how should I say this? I know what specific things I want, but what specific products I want to buy. Um, how do I say this? It's kind of like I know I want a guitar. I don't want a guitar in this case, but like just as an example, I know I want a guitar, but I need to do research and figure out what type of guitar I want. Acoustic, electric, bass, um, I don't know, classical or whatever, what type of guitar I want, which brand of guitar I want, whether I want it to be electric or acoustic or whatever. All of that stuff, I have to do some research on that. And then also price. Price is also definitely something that, you know, uh, affects things because I definitely don't want to be spending too much money on these things. The whole idea is to buy cheap stuff because this is all for hobby projects. And man, I was thinking about this yesterday. I'm slowly building this sort of catalog of a bunch of different hobby electronics things. Um, Recently, I organized my workbench, not completely, but like a decent. I spent some time organizing it to a certain extent, and um, it's much better than it was before. It's much less of a mess than it was before. Um, Yeah, yeah. Why was I saying this? Oh, yeah. This is to say that like now I'm realizing that I'm slowly building up this catalog uh of electronics things. I'm not sure what to say. I'm slowly building up my inventory of components and modules and tools and microcontrollers and stuff like that. And yeah, that makes me pretty excited. That makes me happy because there's so many projects that I have in mind, and in the past, when these kinds of projects have come in my mind, didn't really, I wasn't able to do anything with it because, for one thing, I didn't really know too much about, uh, well, I didn't know too much about communicating with external modules. But there's also the fact that I didn't have the modules to begin with. So, for example, if I wanted to do something, something with DC motors, something that involved DC motors, you can't power a DC motor directly off of an ESP32. It's going to pull way too much current and then damage the pins. So instead, what you need to do is use a dedicated DC driver module, DC motor driver module, where you connect the. It gives you, I don't know, two channels. Some might have four channels. I don't. I think at the very least you'll have two to four. I'll have to get up and look at the DC modules that I have, um, the DC motor driver modules that I have. But oh, actually, I could Google it real quick. I don't remember the exact model number, but let me just Google DC driver, um, DC motor driver module, because I remember what the thing looks like. Um, Give me a second here. Yeah, I think it's this one. I think it's a L298N, and it has, I believe, two. I believe it has two channels, so you can probably control two two motors with it, and I think you also get four channel ones as well. But I'm pretty sure I have the two channel one. And what how this works is the driver module itself gets power separately. Like it has dedicated power slots, dedicated like VCC and ground. So you don't give VCC from the ESP32. Instead, you give it from an external power source. That external power source could also be powering the ESP32, but the wire from the power source has to be going directly into the module, and then one can also go into uh, one line can also go into the ESP32. So the same power source is powering both the ESP32 and the module. However, the important thing is that the module is not being powered by the ESP32 directly. And then you would connect the ESP32 to the module specifically only for control purposes. So there are certain pins which are for controlling only. I don't remember what protocol is being used. Maybe SPI, maybe I2C, or something else, maybe something simpler. I don't remember. But you specifically use it for control purposes. You don't use the ESP32 to power the module, and because of that, because the module is getting power externally, it is then able to power these motors using that external power source, and so you're not putting an extreme load on the ESP32 itself. I forgot why I was explaining this. I think I was explaining this because I was saying that I in the past I had ideas for stuff that I wanted to do, but then I wasn't able to do those projects because I didn't have the modules, and usually I have to wait for a minimum of 2 weeks before I'm able to get my shipment. Like I'll place the order, and that is assuming I place the order on that day or on the next day, which also doesn't usually happen. It's like a whole planning process. Oh, hold on. I think I'm losing internet. Um, we are dropping frames. Oh, you know what? I can try to reduce the load by doing some things. We can close this. I don't think anything else is putting too much of a load. Hopefully we should be good. Yeah, okay. So, like I was saying, um, generally what would happen is I would get these ideas, and then I would find out, oh, I need a dedicated module for this purpose. So I need to place an order for this. And then it, the shipment alone takes anywhere between 1 to 2 weeks. But then me placing the order itself, because I usually gather up a bunch of items in a list and then place an order for all those items. So I get like, the entire shipment at once. So it just ends up getting delayed but whenever I want to do some kind of project. And because of that, over time, I've like ordered a bunch of different things, LCD modules or LED. Let's say TFT displays, TFT display modules, servo motor drivers and servo motors, DC motor driver modules, and there were some separate robotics kits that I had ordered, which had DC motors in them, and they also have a frame. So um, I'm actually planning on using that for a separate purpose. So like the robotics kit itself, it was a small like two-wheel platform kind of car two-wheel platform kind of car. That doesn't even make sense. It's like a how do I even explain this? I have to show it to you guys. Give me a second. I have to do just a small Google search. Um, robotics car. Oh, what just happened there? Hold on. What just happened there? Are we good on stream? I think we are good on stream. Okay. Yeah, this is the best I can think. Robotics kit, robotics car kit, something like that. I'm just googling this real quick because this is actually great for learning purposes. Though in my case, like I what I bought, I'm kind of hacking it rather than assembling it exactly how it's supposed to be assembled. This was one of the simpler, like cheaper ones. It wasn't something so expensive. Like I look at robotics kit and there's like expensive stuff popping up. What I got was a simple kit. It's supposed to be like a four-wheel drive, but it's not. Well, it's not supposed to be four-wheel. It's supposed to be two-wheel, and just so it doesn't tip over, so there's something in the front. In the front, they've put like some kind of I don't even know what to call it, but uh, hold on. I'm just looking for. I think I found. Yeah, I think I found the one. Robotics um, DIY car kit. Maybe I shouldn't use the word car because car is bringing up four wheels, whereas oh god, what did I just click? Yeah, let's close that. Huh. Give me a second. Oh, I think I found it. I think I found it. What is this thing called? DIY electronic kit? Oh, yeah, I found the exact thing to look for. DIY smart track car. Smart track car. So the interesting thing with this is that what they did is they set up the entire circuitry using only discrete components and one or two ICs, but it's not microcontrollers. They used ICs and discrete components to set up the entire logic uh, of the circuit. And there's also an ultrasonic sensor, I believe, that comes with this kit, or maybe it's a simple some kind of sensor was used. I don't remember exactly what I don't think it was a ultrasonic sensor, but man, I'm trying to look for this cheap kit and I'm not able to find it. But when I look it up, well, okay, I am able to find it. It's just that, right, hold on. I did find it. I just want to be able to show it on stream. Uh, this one. Okay. Right. So I'm just gonna real quick do this. Okay, so this and actually this. So these two on the left side, both of these. I think even the center one and maybe this one. No, not this one, but this one on the right. Pretty much, this is what I ordered. Actually, this is exactly what I ordered. Now that I think about it, this is exactly what I ordered. Maybe mine only had one motor. I don't remember if it had one or two. I think I did aim for two motors just so I could like control them independently and also actually no, I think it does come with two motors because otherwise you can't turn the vehicle. But yeah, this is what I'm talking about. This I ordered two of these, and there's no microcontroller involved here. They've set up the logic using discrete components and an IC, and the IC I believe is some kind of comparator. Give me a second. Okay, yeah. So the IC I believe is some kind of comparator. Um, Let me look up what exactly. Okay, comparator. LM. It started with LM. The name was starting with LM. I don't remember exactly which LM it was because I'm seeing a couple popping up here. Let's say LM393. And this is actually what introduced me to the concept of comparators. I'd looked into comparators like a while back. I never really got a chance to do much with them because, well, I didn't have the ICs at the time. I I think I'd looked into it when I was learning about 555 timer ICs because the timer IC internally it does contain a couple of comparators. Okay, just a second. Okay, so yeah, like I was saying, this is what I ordered. This is a kit. It comes with these parts. It comes with two DC motors and a battery case and this comparator IC. And I think these are some sort of like variable resistors or something. I don't remember. Then there's LEDs. There's some kind of sensor somewhere. I don't remember exactly where it was. Um, and capacitors and transistors and a couple more things. Pretty sure there might be resistors in there as well. What I'm planning on doing is I'm gonna use this because the great thing is that this comes with this frame, right? We get this, we get the wheels, we get the frame, and this thing at the bottom that I wasn't sure what to call this because this isn't exactly a wheel. It's just like a nut, a nut with a screw kind of ending, and that's just screwed into this. And the bald edge, the bald end of, or the rounded end of the nut, it's basically like a half dome kind of thing. Actually, a dome is a half sphere. I don't think half is necessary to say. It's kind of like a dome, so it's a smooth kind of surface. So you can actually use this, and I believe that's provided as well. I don't remember if it is. Uh, Dude, you know what? We could actually assemble that on stream as well. Though, okay, here's the thing. I'm not planning on assembling this circuit exactly. As interesting as this circuit may be to assemble and learn about, because this is not using a microcontroller at all. It's using discrete components. Um, Give me a second. I just realized that I did not open up my chat on my phone. So let me just do that. Okay. So, like I was saying, what was I saying? I was saying something about, oh yeah, as interesting as it is that this entire circuit has been set up, this entire logic for the circuit has been set up using just discrete components and an IC as well. Um, as great as that is, that's not what I'm looking for. What I'm looking for is using a microcontroller, because with a microcontroller I can do much more sophisticated things. I also need to think about how I'm gonna get space on this. Something I could do is I could use one of my ESP32 C3 Super Minis instead of using the big ESP32, because the driver module, the motor driver module, is it's big, so that alone could take up the space of this battery case. Oh yeah, then there's also the the question of like how am I going to power this? Because I was planning on powering it off of a power bank. I need to go and get like tiny power banks. I need to look for like the tiniest power bank that I can find. Um, or because I do have Lion, what do you call that? Lion battery charger modules. Like I bought the modules, but I haven't really had the chance to go and buy the battery pouches. I don't actually know where to look for them, and I'm not too sure about ordering them online. Um, if I am buying it, I would be a little more comfortable with buying it locally. Problem is, I don't get out much, and I would actually have to go and look for these pouches because this isn't something that's just sold everywhere. I have to go in like specific places. And if I go into like specifically electronics places, there's a chance that there might be like a markup of some sort on it. But this is exactly what I would be looking for. I would be looking for one of these batteries, and then the battery would need to be charged using the charger module. And once the battery is charged, then the entire thing can be used. Where was I going with this? Yeah, okay. So my idea was to set up the entire circuitry here using an ESP32 and the DC driver module. And the ESP32 is going to be the brain in this case. It's not that big, so I can like stick it anywhere. Fortunately, like the bottom of the ESP32, it's actually, speaking of bottom, what if I stuck the ESP32 to the bottom of this frame? I could do that. Though I would need to be really, I would need to be really careful with driving this thing because I wouldn't be paying too much attention to what's going on beneath the ESP32. Also, that would then make it a little complicated to program. There's definitely that issue as well. I need to set it up in such a way that it's very easy to just plug the thing into like a USB cable and then reprogram it. Yeah, I'll have to think of a way to set this up. Something I could do is I could try extending the platform somehow. Like maybe I could take an extra piece of plastic and like make the platform a little wider or something like that. Just give it a little more room. Fortunately, the ESP32 itself is pretty small, so that shouldn't be a problem. The driver module is not small, so that's going to take up the space of the battery pack, or, well, in this case, the battery case, the battery holder. Then we also have the issue of actually powering this entire setup. Like how is it going to be powered? Yeah, okay. So I'll set the thing up, and then later on I can think of, what later on I can think of all the, I don't know, engineering related issues. For now, dude, we've got this shopping list to prepare. Okay. Um, so I was looking at piezoelectric speakers. I was having a conversation with Gemini about this, and from the conversation, I realized that I need a passive piezoelectric speaker, not an active one, because the active ones, they have internal circuitry that uh, how do I say this? They limit, or it limits the working of the piezoelectric speaker. So you're basically just giving it on off signals, and based on those signals, it's gonna sort of beep or not beep or whatever. But the point is that you are severely limited in what you can do with an active piezoelectric speaker. So you can't really have different tones in your speaker. You can only have like beeps. So it's like a fixed tone, and that fixed tone, you can control the amount of beeps in it. But I'm looking for something a little more sophisticated than that. But I also found out that apparently with the more sophisticated ones, you cannot directly power, or should not directly power it off of an ESP32, because piezoelectric speakers, while they would only slightly exceed the max current that um, an ESP32 pin is allowed to draw or able to give out, while they only slightly exceed that limit, they still exceed the limit. So it's still bad for the health of the board and the pins and stuff. So to avoid damage, um, we can put a transistor in and use the transistor as an electronic switch. So then the power will be coming from directly from a 5-volt source, either from from the ESP32 if it does have a 5-volt out pin, or we can get the power in from like an external source. Though there I would need to consider ground, like how I'm going to be sharing ground. Well, okay, no. I could, yeah, yeah, nope, definitely. I would need to consider how I'm going to be sharing ground. Actually, ground can be shared with I need to see what the difference would be between sharing ground with, in this case, because okay, here I have this idea, right? Um, Hold on. Can I wait? I'm curious. I'm curious about something here. Um, what's going on here? Okay, yeah. Actually, I'll need to open this up again. So let me just keep that open. Here, what was I trying to do? Oh, yeah. Let's open a new thing. I can close it later on. Scratch stuff. We can go into the empty directory. And here I need to create some graph o1 dot dot. Let's also cd into this. Now I don't know. Okay, so we would probably make a graph, some graph o1. Actually, this will be our circuit. I'm curious about something. Um, so let's do node, and then well, node o1 and node o2. Is it possible? What if I want like a circular kind of thing? Is that gonna work or not? Let's see. So we connect node O1 to node O2, but then we also connect node O2 to node O1. So let's see if this actually compiles. Um, what am I looking for? Dot tpng output. I forgot what the entire format was. Okay. Dot files. Okay, so the dot file comes at the end, and all right. So dot tpng output. I think it's just O, isn't it? Yeah, I think it's just O. Where does it mention that flag? Okay, whatever. Um, O, um, some graph o1 dot png, and here I want to pass in some graph o1 dot dot. Okay, so I think that worked. If it worked, then I want to run kitten icat some graph o1 dot png. Okay, so we have multiple connections here. Great. Now, here's what I'm trying to do. Okay. Let's first define our circuit, or let's first define all the components in the circuit. Actually, how do I define ground and VCC? And there have to be three things going in from three pins for the transistor. So we'll say our MCU, that's one node. Another node is our power source. Then we have speaker, transistor, and what else? I think that's it, right? Yeah, I think that's it. We can get rid of this, and then I can start. Okay, so from the power source, I need to go back to learning about this dot syntax because yeah, I'm just remembering that now. I need to go back to learning about dot syntax. Okay, power source. Power source goes to MCU. Okay, power source also goes to the transistor. Then MCU goes to, actually, wait, we are connecting both of these. So power source, then power source to transistor, transistor to MCU, or I could say MCU to transistor as well. But yeah, and then transistor goes to power source. Now let's see how this looks. Speaker. I didn't do anything with the speaker. Okay, so transistor. So the MCU is connected to the transistor, right? And yeah, let's say it like that for the sake of making that clear. I mean, either way, it doesn't make sense. Not sense. Either way, it doesn't make a difference. Transistor goes to power source, and then what else? So the transistor is supposed to. Oh yeah. So then transistor goes to speaker, and speaker goes to. Dude, you know what? If this is the case, like if I'm doing this anyways, why don't I just learn how to define? Let me ask Gemini if this is a thing. Well, I have this instance open, fortunately, so we can do that. Give me a second. Let me open up a new thing here. CD into scratch stuff, empty, open up Gemini here as well. And oh, wait, what did I just do? Oh, I closed this. And something is going on here. Oh, this is my conversation about, okay. This was the conversation where I learned about post-market OS. This is the LLC thing. This is this. Okay, all right. What was I going to look up? Yeah. Hey, so I've been learning the dot graph syntax. It's great for creating flowcharts, diagrams, graphs, etc. Um, I'm doing the manual method, describing the entire graph in code. I'm wondering if there's a similar thing for describing electronic circuits um, through a similar syntax. Something that would not require me to um, download, install, and run an entire editor. Just to make a circuit diagram. Because I have looked into applications in the past, and I did install one. I forgot exactly what it was. I don't remember if it was. Yeah, I forgot what it was. Was it Spice? Maybe it was Spice. I don't remember. Um, but yeah, that it was great. But like you would be using an editor there, and I'm trying to find something where I can just. Oh God, wait, stop! Don't use. Um, change the model. Change it to this. Now, I wonder if the request still counts after I've like canceled the request. It shouldn't count, right? I think it should count after. Okay, I'm not sure why it was trying to list the directories here. Searching for text-based electronic circuit diagram language. Okay, cool. All right. Oh wow, there's a lot of information here. Thought. The search results clearly indicate that the user. I think the response is a bit broken because it's giving me its thought. The user's original request. Oh, is that what I'm looking for? Hardware description languages like Verilog, VHDL, and so on. Or netlist formats like Spice, which are text-based. I didn't know Spice is also a language. Okay. The diagrams package, which I initially considered, is more for architectural diagrams like cloud services rather than low-level electronic circuit schematics. Okay. Where's the answer? Since the user is so-and-so, let's search for a simple. I think this response is a bit broken, dude. Um, oh, what just happened? What just happened, dude? Um, right. Hey, could you... No. Hey, I think your response is a bit broken. Could you rewrite it for me? Okay. Wait, this was your response? That's crazy. Yes, text-based syntaxes exist for describing electronic circuits, similar to dot for graphs. These are primarily HDLs like Verilog and VHDL for digital circuits, netlist formats like SPICE for analog circuit simulation. Yeah, mine is not analog, that's for sure. Give me a second here. These allow for defining it in text, avoiding the need for graphical editors. Would you like to see a simple example? If I'm mainly doing projects using ESP32, which one would be suitable for me? And is there, or, and well, not is there, I should say how. And how do I go about rendering the graph after the coding is done? Dude, I'm supposed to be preparing this fucking shopping list, man. What am I doing? Let's come back here. Where is where did I put the shopping list? Here. Okay. Dude, I recently discovered this dimming thing in NeoVim. This is really useful, especially like if you're doing text editing, it's great. It helps you focus on where exactly you currently are. This is what it looks like without dimming. So here you see the entire text. And if there's like lots of information, then you might not be able to focus. So this kind of thing definitely helps. I mean, it depends on, you know, it'll depend from person to person. Maybe for some people it might not be that helpful, but like I found this really interesting. And this is great for code as well. Um, it 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 can highlight entire like functions or blocks within functions and leave the rest of the code dimmed out. So I can definitely see this being useful, especially if you have like a bigger screen, um, and you have like lots and lots of text or code or whatever being displayed. This can be really useful. Another very useful thing is the Zen mode thing, but like I don't need that a whole lot. I can use it later on if need be. Currently, the only thing that it's disabling is the tab line, which I don't need to be disabled. I can like I kind of need to see which files I'm currently working on. But yeah, dude, this is really useful. Okay, let's take a look at Gemini's thing here. For ESP32 projects, the most suitable text-based approach depends on what aspect of the circuit you want to describe. Digital logic design, if interfacing with FPGAs. If you're designing custom digital logic blocks, like digital logic blocks to work with your ESP32, example on an FPGA, Verilog or VHDL are the standard hardware description languages. They are text-based and used to define the structure and behavior of digital circuits. So that's not what I'm doing. Analog circuit simulation. For designing and simulating analog components around the ESP32, like power supplies, sensor interfaces, SPICE netlists are used. This is primarily for simulation rather than schematic visualization. Okay. However, for the common task of connecting an ESP32 to sensors, actuators, or other peripherals, example, creating the overall system schematic, text-based text-based description is less common. Graphical schematic capture tools are standard for this. Okay. All right. The GraphViz diagraph in the code snippets you provided. I didn't provide that, but you read the file, didn't you? Uh, Okay, fine, whatever. Um, you provided is used for visualizing software agents and workflows, not electronic circuit elements. Therefore, while Verilog, VHDL, and SPICE are text-based schematic description languages, they require specific EDA tools for rendering schematics. For typical ESP32 hardware connections, graphical tools remain the standard. Okay, this isn't helping. I'm trying to find a simple way to describe my circuit using text-based language, um, and then render it using um, some sort of CLI tool. Okay. Yeah, actually, you know what? I remember seeing a tool, a library, in fact, in that was made for C Sharp, and I think it was connected to Spice somehow. Um, that was a library where you could define your circuit in C Sharp code, and then that could be rendered. I remember that. I remember that. At the time, though, I stepped away from that because I wasn't looking for something that I would have to define in code. Now I'm looking for something I have to define in code. But back then, I was looking for an editor specifically. Okay, I understand you're looking for. No, I understand. You're looking for a text-based approach to describe circuits and render them with a CLI tool, similar to how dot syntax works for graphs, and you want something simple, particularly for ESP32 projects. While Verilog, VHDL, and Spice are text-based, they are often used for detailed logic design or simulation and require specialized tools for rendering schematics, which might not be the simple CLI tool experience you're after. Let's explore just a second. What is going on here? Are we good? Uh, hold on. I'm a little bit confused about this. Oh, okay. Right. I think. Hold on for a second. Just a second here. I don't need this to be open. Okay, now while those are closing, let's see if any of that helped. Yeah, it helped. It helped a bit. Okay, all right. I think we're good. Now for this response. No, don't do that. Rewrite the response, please, but don't take any actions. I just want the info. Oh, wait, I didn't switch from BRB. Completely forgot that we were on BRB. Yeah, I was trying to solve a little memory issue that I was having. Okay, okay, I understand. You're looking for information on a tech. Yeah, fine, great, awesome. Based on the search, SchemDraw. Okay, SchemDraw is a highly recommended Python library for creating electrical circuit schematic diagrams from code. This aligns with your need for a text-based approach that can be rendered using CLI tools, avoiding the need for graphical editors. CLI rendering. SchemDraw can export diagrams to formats like so-and-so, so-and-so. Interesting. Okay, interesting. What other such tools slash libraries exist? I'm going to look at SchemDraw real quick. SchemDraw is a Python package for producing high-quality electrical circuit schematic diagrams. Okay, this is a pretty old package. Let me just Google circuit diagrams through code. Is it possible to draw circuit diagrams through code? So this is from 2017. I need to look for, okay, PyCirc tools, circuit graph, and PyCircuit. Okay, is there anything Rust based? Though I probably should go with Python because it would be simpler to, like, it would be simpler to define the syntax, or not define the define the circuit, because it's less verbose. But yeah, I'm just curious. A user-friendly program for making electronic circuit diagram. Okay. Okay. Cool. What is this made in? C sharp. Hell yeah. Okay, the search revealed SVG Bob, a Rust-based CLI tool that converts ASCII art diagrams into SVG images. While it's text-based input and CLI render, while it's a text-based input and CLI rendering tool, it's generic and doesn't inherently understand circuit specifics. So at present, that doesn't appear. No, no. This is not giving the entire information. Hold on. Text-based circuit diagrams. Wait, dude, what am I doing? What? Hold on. I got way too distracted here. Hold on, quit this, quit this. We need to go back to um we need to go back to this. So, piezoelectric speaker. I know I need a passive one, so I'm just gonna look for that. Okay, while I have this Gemini tab open, give me a second here. Okay, so in this case, um, would the transistors uh, connection to ground go to um, go to the ESP32 GND or to the um, external power sources GND. Oh God, why is everything slowing down so much? Hold on. Yeah, it shouldn't be slowing down. We're not running out of RAM. I think it's just Firefox. Yeah, I think it's just Firefox. Let's look up piezoelectric um, speaker. Okay, it's not. I shouldn't be looking up speaker. I should be looking up buzzer. Yeah, that's more what I'm looking for. I'm not looking for active ones. I'm looking for passive ones. So let me also mention passive. Okay, this is great. It mentions some of these mention active slash passive. Like, what am I supposed to make? What am I supposed to make of that? Okay, I found passive ones here. 10 piece passive so and so. Hold on. Let me sort by order. Okay. So I've found buzzers here. I need to get buzzers that are already wired because I don't want to have to spend time soldering wires onto them. They are pretty cheap. However, somebody left a comment saying terrible, terrible performance. I do not recommend. Wait, this only has hold on. I'm looking at the wrong thing because the one that I opened up apparently only has two. They've only sold to two or four, and there's only two reviews on there. I'm looking for the one that is sold to 2,000, as in sold 2,000 of them. Okay, um, what does this say? Piezo buzzer, IC station buzzer, alarm 12V electronic. I should probably mention 5V. Or better yet, 3.3V. Actually, this is going to be 5V because I'm not going to be powering it off of the ESP32. Though, um, if it's a 5V buzzer, is that like a max thing? So like, could we technically power it um, off of 5 volts? Okay, arrived on time, excellent product. I mounted them on my motorcycle as indicators to avoid forgetting to turn them on. They're loud enough to be on your bike. Arrived very quickly, good product. The noise is very loud, excellent gurgling sound. I recommend this. What? Hold on. I often forget to turn off the turn signals on my bike. A lot of these people seem to be buying this for a bike. This is not the first time I've ordered this product. The package arrived quickly and well packaged in sturdy containers. I recommend this seller. Okay, great. No complaints about the seller or delivery. Hold on, let me take a look at the. Because these are 12 volts. I'm looking for 5 volts. Oh, better yet, there's 3.3 volts as well. If there's 3.3 volts, actually, if there's 3.3 volts, I might be able to power this directly from the ESP32's 3.3 volt out. But I have to see like if there's a current draw limit on that pin. 5 volt passive buzzer, 10 piece, so and so, so and so. Okay. In electronics, the golden rule is all grounds must be tied together. If you are using an external power source like a battery pack or a separate 5V adapter to power the piezo, you must connect the ESP32 ground and the external power ground to the same common point. Why does it matter? Voltage is electrical pressure measured relative to ground. The ESP32 sends a signal from the GPIO pin at 3.3 volts relative to its ground. If the transistor's emitter is connected to an external ground that isn't linked to the ESP32, the transistor won't see the 3.3 volt signal correctly. It would be like trying to measure the height of a building while standing in a hole. The reference point is missing. The final circuit layout. Um, Wait, in this case, we also need a diode. Holy shit, this circuit is going to end up becoming a little more complicated than I thought. I didn't know that there would be like a back EMF kind of thing, even from these piezoelectric buzzers. Um, okay, for clarification, the idea I had in mind was that I would have power coming in from a wall wart, um, a 5V wall wart, um, basically a phone charger, and then split that into um, the ESP32 and the transistor. Now, for the ESP32, since there's a USB cable going in there, we have VCC and GND. For the transistor, VCC is coming from the power source directly, and then the middle pin is connected to some GPIO pin on the ESP32. That's why I was wondering where the ground connection for the transistor should go. Okay, that is a very common way to power your project. Using a single 5V wall wart ensures both ESP32 and the speaker have plenty of current. Since you are splitting the power from a single source, your ground is naturally shared but you still need to make sure the physical connections complete the loop. Where the transistor ground goes, the transistor's emitter, the bottom pin, should go to the same ground line that feeds the ESP32. If you are using a breadboard, your main ground rail connected to the negative wire, connect the negative wire from your 5-volt wall wart to the long, okay, so that's our ground. Then ESP32 ground, connect the ESP32's ground pin to the same rail. Then the transistor ground, connect the transistor's emitter pin to the same rail. Understanding the middle pin. You mentioned the middle pin connects to the GPIO. A quick warning, check your transistor's data sheet. While many so-and-so have the base, the signal pin in the middle, others have a different layout. Oh, okay, yeah, that's fine. Always use a resistor. Never connect ESP32 GPIO directly to the base pin. Use a 1K or 2.2K resistor. I actually didn't know that. This limits the current leaving the ESP32 and prevents the transistor from pulling too much juice. The power split logic. Since the ESP32 has an onboard voltage regulator, it will take the 5V from the USB/VIN pin. And actually, you know what I'm wondering? I'm wondering if after I have programmed the ESP32, would it be possible to, though how would I test out that code then? No, you know what? I think yeah, I think even the USB the USB port from the computer could provide enough voltage, actually enough current. How much current can um, PC USB port max current? PC USB port max current varies greatly. Standard USB is 0.5 amps, which is 500 milliamps, and USB 3.0 is zero point 0.9 amps, which is 900 milliamps. While modern USB-C with power delivery can negotiate much higher, often up to 3 amps by default, or even 5 amps, uh, with specific cables and host support enabling laptop charging. The device plugged in pulls the current it needs up to the port's limit. You know what? It's a small speaker. I don't think it's going to be pulling that much current. Hopefully, it's not going to be pulling that much current. Hey, so I'm wondering something. The ESP32 has a USB port that I can plug a power source into to power it. But is it possible to use, or is it possible to, um, yeah, is it possible to use one of um, the pins to power it? I understand that there's um, a voltage regulator involved. Um, I believe it's the voltage regulator that's taking the 5-volt down to 3.3 volts involved, or some other circuitry um, to handle the conversion from 5V to 3.3V so the chip doesn't get fried. But I'm wondering if I can plug 5V directly into one of the pins, um, made specifically for that purpose? Because I'm curious about what VN takes. Okay, yes, absolutely. Most ESP32 development boards, like the popular Do-It DevKit V1, are designed exactly for this. While the ESP32 itself runs on 3.3 volts, the development board includes an onboard linear voltage regulator, typically so-and-so model. This regulator's job is to take a higher voltage and drop it down to 3.3, drop it down to the 3.3 volts that the chip needs. The power pin, V in or 5V. You can plug your 5V wall wart directly into the pin labeled V in, 5V, or VCC. Okay, so this is going to be a little bit complicated because how am I powering the thing from a external voltage source while also being able to actively program and test it by connecting it to a computer? Yeah, I'm gonna have to do some research on how that whole connection works. Okay, the power pin V in, crucial safety rules. Never use the 3.3 V pin for input. Do not plug 3.3, do not plug 5V into the pin labeled 3.3V. That pin is an output from the regulator. If you put 5 volts there, you will bypass the regulator and send 5 volts directly into the ESP32 chip, which will likely kill it instantly. Okay, shared ground. Just as we discussed with the transistor, the negative wire from your 5-volt power source must go into one of the ground pins on the ESP32. USB plus V in conflict. On some cheaper boards, if you have 5V plugged into the VIN pin and you plug your USB cable into the computer at the same time, they might fight or backfeed power into your PC's USB port. Safe bet, unplug your external 5V source before plugging in the USB. Okay, yeah. So, so the safety info you gave brings me to my next question. Let's say I have an ESP32, a DC motor driver module, and a DC motor. Since the motor, no, the motor is connected to and powered by the module. Since since the motor's current draw is way too much for the ESP32 to handle, we need to provide an external power source. Uh, the power source could be powering both the ESP32 and the module. Oh, I should mention we need to provide an external power source going directly into the module. The power source could be powering both the ESP32 and the module. And then the ESP32 could be connected to the module solely for control purposes. This works fine if the ESP32 has already been programmed to do um, stuff with the motor. Um, but what if I'm currently in the process of writing the logic for the ESP32? Um, I can't connect. No, I can't power the ESP32 and the module off of a USB port on a computer. I feel like the current draw is too much. How do we go about the setup in this instance? Okay, this is a classic development versus deployment headache. You are absolutely right. You are absolutely right. A computer USB port is usually limited to zero point 0.5 amps to zero point 0.9 amps, which is plenty for an ESP32, but nowhere near enough for a DC motor under load. Okay. If the motor tries to pull more current than the USB port can provide, your computer might shut down the USB port for safety, or the voltage will drop so low that the ESP32 crashes, which is a brownout. Okay, good to know that it's not going to fry the USB port. Good to know. Here's how you handle this setup safely while writing and debugging your Rust code. The common ground setup. You should power your ESP32 via USB for programming/serial logs, and the motor driver via the wall wart. But keep their grounds tied together. USB cables. USB cable is plugged into your computer and the ESP32. This provides power for the chip and the data path for your Rust print line logs and DFMT traces. Then external 5 volt or 12 volt power connected only to the VCC/VM and ground pins of the motor driver module. Okay. Okay, hold on. So we are not connecting this anywhere near the ESP32. We are connecting this directly to the motor, or to the motor module. Okay, the bridge, connect a wire from ground of the motor driver to a ground pin on the ESP32. Then control lines. Okay, so I'm guessing this is how they share ground. Connect the ESP32 PWM pins to the driver's input pins. Why this is safe. The motor driver and the ESP32 now share a reference point, which is ground, but their high voltage sources are isolated. The motor pulls its heavy current from the wall wart, while the ESP32 pulls a tiny current from your computer. Then the Schottky diode protection. Advanced way. If you're worried about backfeeding, power flowing from your wall wart back to your computer's USB port, you can use a diode for you can use a diode. Most high quality ESP32 boards have a diode between the USB 5V and the V in pin to prevent this. However, if you want to be 100% sure, place so and so Schottky diode. I'm going to need to see if I even have. Actually, yeah, wait. I have a box of diodes that I ordered, or maybe it was one specific kind of diode. I don't remember. Hold on, let me grab the box real quick. Okay, so I have the box here, but um, the box just says 8 values, diode box, 100 pieces, and then there's all the diodes in here. I need to learn how to read these diodes in order to figure out which one is a Schottky diode. Um, yeah, I'm gonna need to spend some time learning how to read, because like with capacitors, you have the capacitance and the max voltage mentioned on the capacitor. With resistors, um, you have those the color bands, which you can look at the resistor color code chart and figure out that this is the value. These diodes, well, fortunately, I have 8 different ones, so I can probably make something with it. See, this is what I was talking about at the beginning of the stream. That I've at this point, like I've bought a bunch of things that no, I've bought so many different things in like bunches, um, and in some cases, it's like I bought like assorted boxes. So an assorted box of there's an assorted box of capacitors. There's assorted resistors, which I sorted that out into, I don't know, what is that, 12, 15 different values. Like I got multiple values there, and that's, dude, that's great. That's amazing. And in fact, there were so many values that I kind of had to bin them together. I think I'd done a stream where I was binning the values of the various resistors that I had. I had like all the way from a couple ohms, like from a couple ohms going all the way up to um, I don't know. I think maybe I had like 1 million ohms as well. And those are like, surprisingly, those are like tiny ass resistors. Though I think their size kind of dictates how much power they can dissipate, and you probably don't want to be using those tiny ones for circuits that use a lot of or produce a lot of power. I think so. I think that's the reason behind like them being so massive. Anyways, Schottky diode on the wire going from your 5V wall wart to the ESP32 pin. You wait, we put a diode from the wall wart to the ESP32V in pin. This diode allows the wall wart to power the ESP32, but prevents backup. I'm not powering the wall wart. I'm not powering the ESP32 from the wall wart. I think it's kind of confused here. Because in this specific example, okay, hold on. The diode allows the wall wart to power the ESP32 but prevents electricity from traveling backwards towards the USB port. Okay, safety tip, the propeller off rule. When writing Rust code for motors, do not attach the motor load. While testing your logic, PWM frequencies, duty cycles, etc., keep the motor disconnected from the driver or remove the propeller wheels. Use the enable pin. Most drivers like so and so, so and so, so and so have an enable pin. In your Rust code, keep this pin low by default. Only set it high once your initialization logic is finished. I didn't know that. I didn't know any of that. Handling spiky motors in Rust. DC motors are noisy electrically. They create electromagnetic interference, EMI, that can travel back through the wires and crash your ESP32. Hardware fix: solder a small ceramic capacitor across the motor terminals. This eats the high frequency noise. Rust fix: in your ESP HAL code, you can implement a soft start. Instead of jumping from 0 to 100% duty cycle, which creates a massive current spike, use a loop to ramp the PWM duty cycle up over 500 milliseconds. Okay, summary of wiring for development. So ESP32, computer via USB, motor driver VCC, external power, motor driver ground, external power, and ESP32 ground. Okay, okay. And then control pin, control pins, ESP32 GPIOs. Okay. Um, I'm confused about the Schottky uh, diode solution you mentioned because the wall wart isn't going into the ESP32. It's going into the driver module. This is a great catch. You're right to be confused because I was describing two different power scenarios at once. Let's separate them clearly. If your wall wart is only plugged into the motor driver and the ESP32 is only plugged into your computer via USB, you don't need the diode. However, there is a specific reason why people often bridge that 5V line, and that's where the danger and the diode comes in. Scenario A, isolated power, your current plan, ESP32 powered by USB on the computer, motor driver powered by wall wart. Connection: only ground and signal pins connect the two. Okay, yeah. Verdict: no diode needed. This is safe because the 5V from your computer and the 5V. What's the max that these modules can handle? I haven't looked into that. What was it? L298? Yeah, L298 motor driver. What is the max voltage that these things can? L298N. Let me look this up. Maybe on Spark Fun we can get information. Oh, I can just look up max voltage. Oh God. Okay, the chip supports a maximum voltage of 46 volts, but typical modules have onboard capacitors rated for around 35 volts. That's still way more than what I was planning on putting into it. Anyways, the maximum supply voltage for so-and-so driver is 46 volts. True, but not for the module. The 35 volt max supply caps voltage and dissipation of so-and-so. Okay. Okay, well, shit. So what I was wondering here was, could I plug in 12 volts into it just to get more speed out of the motor? And probably also, give more current into the motor. Though, now that I'm thinking about it, these motors, they are not rated for that kind of power. Um, yeah, the specific motors that I plan on using, they are usually in like low power devices that um, they are usually meant to be powered by anything between 6 to 9 volts, and even 9 volts. When I've plugged one of these motors into 9 volts, it spun like fast. It spun so fast that within seconds the thing became hot. I think the wires would I think the wires would become hot as well because I think the motor was spinning so fast that it was pulling so much current, and the wires that were being used were incredibly thin. So I think that's why the wires would heat up as well. I'm not sure. I'm gonna have to look into why that was. That being said, if 9 volts was too much and the thing would heat up eventually, I think I should stick to 5 volts and probably not try to pump too much. So, I mean, in a way, that's a good thing as well because that means that I can use the same power source, the same 5 volt source. That being said, I do have a question here. Um, okay, scenario B is shared power, where the diode is used. This happens when you want the wall wart to power both the motor and the ESP32. Oh, oh yeah, that would be for deployment. That would be for deployment. Okay, okay. Okay, let's read this. I just realized that. This happens when you want the wall wart to power both the motor and the ESP32, so you don't have to rely on the computer's weak USB power. But you still want the USB cable plugged in to see your Rust print logs. Oh, I wasn't even considering that. So now we have three power sources. Two of them are going into the ESP32, and one is, oh my God. Why? Why though? Like at that point, why would I need? Yeah, no. I'm trying to understand this. At that point, why would I need a separate power source going into the ESP32 if it already has the USB plugged in? Like if the USB is not plugged in, then it's a different situation. Okay, anyways, let's continue reading. In this case, you would run a wire from the Walmart 5V to the ESP32V in pin. Now you have a problem. The computer is pushing 5 volts into your ESP32 via USB. The wall wart is pushing 5 volts into the ESP32 via the V in pin. The conflict: if the wall wart is slightly higher, example 5.2 volts, than the USB port, the electricity will flow backward from your wall wart through the ESP32 and into the computer's motherboard. This can fry your USB port. That's scary. Okay, so we need to be careful with this. How the Schottky diode fixes scenario B. If you want the flexibility of scenario B, you put the diode on the wire between the wall wart and the V in pin. Okay. Direction. The diode acts like a one-way valve. I'm trying to understand how this causes electricity to flow back to the USB. Okay, it lets the wall wart power the ESP32, blocking. It prevents the USB power and the wall wart power from fighting or backfeeding. Hidden connection problem. There's one more thing to watch out for. Some motor drivers have an onboard 5 volt regulator. If you connect the 5V output pin of the motor driver to the V in pin of the ESP32 while the USB is plugged in, you are effectively in scenario B without realizing it. The golden rule for debugging: if the USB cable is plugged into your computer, do not connect any other 5 volt source to the ESP32V in or 3.3 V pins unless you are certain your board has protection or you have added a diode. Okay, so scenario A works for development. For deployment, I would be connecting the same wall wart to the ESP32 and the driver module. Then what? Also, in a situation where I'm using 5V, I'm using a 5V source for the ESP32, but a 12V source for the driver module. How does sharing ground work? And how can I be sure that the 12V circuit isn't gonna accidentally power the 5V circuit? Though in this case, mainly they're sharing ground, right? That being said, there is still that concern that 12 volts might somehow, even if it's making its way to ground, it would somehow go through the 5-volt circuit. Okay, these are the exact questions that separate a hobbyist from a professional developer. Moving from breadboard to, okay, that's great, awesome. This requires thinking about power isolation and voltage references. Okay, moving to deployment. 5-volt wall wart. Once you finish your Rust code and unplug the USB, you need the wall wart to power everything. The wiring. Split the 5V, run one wire to the motor driver's power input, and another wire to the ESP32's V in pin. Then ground, run the negative wire from the wall wart to the common ground that both the driver and the ESP32 share. Okay, that's interesting. That's interesting because what I had in mind was something a bit different, though I'm now wondering like if that would have even worked out. Because what I was thinking was, well, we would have to connect to ground anyways, right? If I'm connecting to V in, I would have to connect to ground as well on the ESP32. And if I'm connecting to V in on or VCC on the driver module, I would have to connect to ground on that as well. So then we could just bridge those two and send them to. Actually, yeah, no, we bridge both of them, but then they both have to come to the actual ground. We don't just bridge both their grounds together. That's not going to do anything. Yeah, ground has to come back to the ground of the power source. Since the USB is gone, there is no backfeeding risk to your computer. The ESP32's internal regulator will take that 5V from the V in pin and turn it into the 3.3V it needs. Then mixed voltages. This is actually the most common setup in robotics because 12V motors are more powerful, but the logic ESP32, the logic still needs 5 volts or 3.3 volts. How sharing ground works. Ground is not zero electricity. It's a common reference point. Think of it like sea level. ESP32 is a 5-meter hill relative to the sea level. Motor the motor is a 12-meter hill relative to sea level. As long as you are both measured, as long as they are both measured from the same sea level, which is ground, the 3.3 volts signal from the ESP32 GPIO will look like exactly 3.3 volts to the motor driver. The setup. Connect the negative terminal of the 12-volt power supply and the negative terminal of the 5-volt power supply together. Connect that junction to the ground pins of the ESP32 and the motor driver. Holy shit. Okay. Okay. That's interesting. All right. How to keep 12 volts from accidentally powering 5 volts. This is a valid fear. If 12 volts touches your ESP32, the chip is toasted. You keep them separate through physical separation and component design. Physical separation, the rails. On your PCB or breadboard, you must have two distinct power rails. The 12 volt rail goes to the motor driver's VM pin, and the 5 volt rail goes to your ESP32's V-in pin and the motor driver's VCC pin. No, back up. Hold on. Oh, logic voltage. Okay, okay. Oh, okay. Yeah. I didn't take that into account. I actually didn't take that into account. Holy shit. Component design. The driver is the wall. Modern motor driver modules like so and so, so and so, so and so are designed specifically to keep these voltages apart. Inside the driver chip, the high power side, um, which is the 12 volt, is physically separated from the logic side, which is the 5 volt. Oh, within the module itself, they have the separation. Okay, the 12 volt is only connected to the motor via H-bridge transistors. The only thing connecting the 12 volt side to the 5 volt side is the common ground. Since electricity always takes the path of least resistance to ground, the 12 volt will flow through the motor to the ground rail and ignore the 5 volt rail. Pro deployment tip. Okay, okay. All right. Enough of that. For now, we need to. Oh, I was looking at piezoelectric speakers. Holy shit, dude. So, piezoelectric buzzers. I have this thing open here. So we have 3 volts, 5 volts, 9 volts, and 12 volts. Am I able to select? No, it's not. It's actually not giving me the option to select. Yeah, that's interesting. Are they all just like max 12 volts? Can they all just be powered by max 12 volts? Okay, let me pop this name in here. Okay, open that up. Open that up. Okay. Hey, so I'm looking to buy piezo. Wait, didn't I have another conversation that I had open? Did I close that? I think I closed it maybe. Yeah, maybe I closed it. Let me open that up again. Um, oh, this was the piezo conversation. Okay, so going back to piezoelectric buzzers, I have a question. So um, I'm looking online for the buzzers, and I saw one seller mention in their listing this. I'm confused about what the voltage actually is because four separate uh, voltages are mentioned. I'm wondering if it's like a max voltage kind of situation. Okay, that listing is a classic example of seller speak trying to cover every possible search term. Here's the actual breakdown of what those numbers mean. The voltage. When the seller lists multiple voltages, like this for a passive buzzer, it doesn't mean that you have to choose one. It means that the buzzer is compatible with any of those logic levels. What it actually means, the buzzer is a universal component. It'll work if you pulse it with 3.3 volts, 5 volts, or even 12 volts via a transistor. The difference, voltage in a passive buzzer directly correlates to the volume. At 3.3 volts, it will be audible. At 12 volts, it'll be significantly louder. The 4-2R resistance, the smoking gun. This is the most important detail in that listing. 4-2R means it has an internal DC resistance of 42 ohms. This is likely not a piezo. Real piezoelectric buzzers have near infinite DC resistance. They act like capacitors. A buzzer with 42 so and so resistance is almost certainly an electromagnetic. Why it matters. Magnetic buzzers use a coil and a magnet like a tiny traditional speaker. They pull much more current than a piezo. Okay. I was about to say, okay, is that better or worse? That's that's a bit worse. Though not that worse if we consider that I was anyways gonna have to give it external power. Um, okay, verdict. Should you buy it? If you're comfortable with if you're comfortable using the transistor circuit, we discussed earlier, these are great. They are cheap and common. However, do not connect them directly to your ESP32. You must use a transistor because of that 42 ohm resistance. If you want a direct connection, look for a high impedance piezo transducer. Okay, I guess this is not what I'm looking for then. Why are these being listed then? If I'm looking for a piezoelectric buzzer, maybe because I'm mentioning buzzer, let's say speaker. Yeah, maybe it's because I'm mentioning buzzer. Oh, there's another thing that I need to look into. So one of these is the electromagnetic thing, right? That's going to need an external power source. Though, okay, wait. Okay, so I'm curious about a couple things. Um, in terms of tone, how are these electromagnetic speakers or buzzers? Um, I'm seeing two different types of buzzers. One is um, a sandy colored disc, which is actually what I had in mind when I first started this search. And the other is um, something that looks like a tiny hockey puck, which is these buzzers we're talking about right now. What was there another question? Oh, um, for actual um, piezoelectric speakers slash buzzers, is passive and active still a thing? And will they also pull too much current? I'm guessing the answer for that is not, it's not too much, but it's slightly more than what the pin is rated for, and so that'll start to deplete the life of the of the pin and the circuitry in general. Okay, this is a great moment to clear up the buzzer versus transducer confusion. Give me a second. Okay, oh yeah, you are looking at two completely different technologies that often get lumped together in search results. The tiny hockey puck is the electromagnetic. The 42 ohms buzzer you found is a magnetic buzzer. Inside is a wire coil and a metal disc. Tone quality. It sounds punchy but metallic. It is excellent for sharp, clear beeps because it uses a physical coil. It has a narrow resonant frequency. If you play a note at its favorite frequency, which is example 2300 hertz, it's very loud. If you move slightly away from the frequency, the volume drops off significantly. Current, as we calculated, it's 78 milliamps. It is a heavy lifter. It requires a transistor. Then the sandy colored disc, the true piezo. Um, this is a piezoelectric diaphragm. It's just a ceramic layer bonded to a brass or stainless steel disc. Okay. Tone quality. These sound thinner and airier because they don't have a plastic housing unless you buy them in one. They aren't very loud on their own. However, if you glue them to a plastic box or table, the whole surface becomes a speaker. That's interesting. I should try that out. Okay. I wonder if that's the reason why it was used um, in like musical greeting cards and stuff. Okay. Um, okay, current. These pull almost zero. Hold on. What? That's. Hold on. That's interesting. These pull almost zero current, usually less than 5 milliamps. They are the only ones you can safely plug directly into your ESP32 GPIO without a transistor. Voltage. They love high voltage. While they work at 3.3 volts, they can often handle up to 30 volts. The higher the voltage, the more the ceramic bends and the louder the sound. Is active versus passive still a thing with piezo? Yes, but usually only for the hockey puck style. Active piezo puck. Okay, the discs are always passive. They're just raw components. That's crazy. Okay, so now I'm a bit confused because earlier on in the convo, you told me that they take around 30 milliamps, they draw around 30 milliamps. I assumed you were talking about the ceramic discs. I apologize for the confusion. That is a very important distinction to clear up. When I mentioned 30 milliamps, when I mentioned the 30 milliamps figure earlier, I was referring to encapsulated buzzers, the hockey pucks, which are the most common ones people buy. The 30 milliamps versus your, what exactly am I supposed to be Googling here then? Hold on. Buzzer versus transducer. This is a buzzer. Piezoelectric diaphragm. Let me look that up instead. How do you spell diaphragm? Okay. Um, oh, we are dropping frames. Right. Piezoelectric words. Piezoelectric diaphragm. Piezoelectric disc. That's what I'm looking for. And then something has to be soldered on there. I need something that's already soldered because I don't want to have to deal with the headache of soldering it. The good news is that we do have sellers that are selling specifically the piezoelectric diaphragm. Oh God. Okay, okay, much better. For some reason, this went into like motors and shit. Piezoelectric buffer, piezoelectric ceramic wafer plate. Maybe I should not write diaphragm. Maybe I should write ceramic. So let's write piezoelectric ceramic buzzer. Ceramic, um, yeah, okay. Piezoelectric ceramic. I'm gonna assume that this can put out sound. I'm gonna assume this can put out sound because these are exactly what um, I'm looking for. Okay, let me see. Right. Okay, the 30 milliamps versus the almost zero difference comes down to whether the component has an internal coil or just a crystal piezo. An internal coil which is magnetic or just a crystal which is piezo. Here's the breakdown of the current draw for the different types you are seeing. Okay, magnetic is 30 milliamps to 100 milliamps. Why it's heavy? Moving that metal disc with the magnet takes a lot of energy. Okay, the mechanism is it uses an electromagnet to pull a metal diaphragm back and forth. Okay, then the piezo hockey puck. He, this is inside a plastic puck. Inside that plastic puck is one of those sandy discs. Okay. the ceramic diaphragm, the current draw, because it's a crystal, it doesn't conduct electricity like a wire, it just flexes when it sees voltage. This makes it safer to plug it directly into so and so. The sandy colored disc, raw piezo diaphragm. Um, okay. Current less than 1 milliamp. I was about to say negative 1 milliamp, but no, not negative. Less than 1 milliamp. Current draw. These are the most efficient. They act like a tiny capacitor to the ESP32. It looks like almost no load at all. The catch, because they are so thin and draw so little power, they move very little air. Without a plastic housing, such as the puck, to resonate the sound, they are very quiet. Okay. Wait, so just because the disc is inside a plastic housing, suddenly it's drawing much more current? No, not exactly. I can see how that sounded confusing. The plastic housing itself doesn't change the physics of the component inside. The confusion comes from the fact that the hockey pucks look identical on the outside, but can have two completely different engines on the inside. It's about what's inside the puck. When you buy a hockey puck buzzer, you are buying one of two things: a piezo puck or a magnetic puck. I like that it's using my analogy, my terminology. Um, this is just a sandy disk. The piezo puck is just a sandy disk glued inside a plastic box. It behaves exactly like the raw disk, low current. Say, okay, dude. Okay, but earlier you said that the piezo puck drew 5 milliamps to 15 milliamps. You caught a very subtle but important detail. I can see how that looks like a contradiction. Let me explain why the piezo puck draws slightly more than the raw sandy disk, even though they use the same technology. The stiffening effect. When you take a raw sandy colored disk and glue it inside a plastic puck housing, two things change that slightly increase the current draw. Mechanical load. The disc is now glued tightly at the edges to the plastic. To vibrate, it has to fight against the stiffness of the glue and the housing. This extra work requires a tiny bit more energy from the ESP32. Internal circuitry. Many piezo pucks, even passive ones, include a tiny resistor or inductor inside the plastic housing to help protect the piezo or tune the sound. This extra component adds a small amount of overhead current. Real world scale. While the jump from less than 1 milliamp to 15 milliamps seems quite a lot, in the world of the ESP32, both are considered low power. A raw disk effectively invisible to the ESP32, and a piezo puck a light load for the ESP32, well under 20 to 40 milliamp danger zone. Mag, magnetic, magnetic puck is a heavy load that can damage the pin. Okay, I remember a while back seeing um, piezoelectric um, atomizers, which were being used to build USB powered um, humidifiers. I'm concerned that I might accidentally be buying one of those discs. That is an incredibly sharp observation. You are right to be concerned. Piezoelectric atomizers, ultrasonic misters. That's what that's the word that I was looking. That's the term I was looking for. Ultrasonic mister. Um, Look almost exactly like the sandy colored disc. Piezoelectric piezo discs used for audio, but they are built for completely different purposes. If you try to use an atomizer disc as a speaker or vice versa, it won't work, and you might even damage the ESP32. I'm guessing because that atomizer disc pulls a lot more current. Because I saw the circuitry that like the thing was connected to. There's quite a lot going on there. There's actually like it's either storing more current or it's stepping up the current using some kind of inductor or something. Stepping up the current or voltage, one of these two. Either way, you need a lot to like power these things. Okay, appearance. Solid ceramic sand layer. This appearance micro holes. A mesh in the center. Okay, if you hold it to light, you see a tiny screen in the middle. All right. Why the atomizer is dangerous. Massive voltage requirements. To turn water into mist, these disks need to vibrate violently. They usually require 24 volts to 110 volts, peak to peak. I don't know what that means. And ESP32's 3.3 volt signal won't even make it flinch. Frequency mismatch. An ESP32 can generate 100,000 kilohertz with Rust, but the speaker code we've discussed is for audio frequencies, which is between 20 hertz and 20,000 hertz. Give me a second here. Okay. Capacitance. Atomizers have much higher capacitance trying to drive. Oh, hold on. All right. Trying to drive that at high speeds directly from the GPIO could create heat and current spikes that would quickly degrade the ESP32. What to look for in the listing: avoid ultrasonic atomization, micropore, mister, humidifier part. Okay. Look for buzzer, sounder, transducer, diaphragm, audio. The blowing test, that's crazy. That is crazy. Okay. If you receive a disc and it has a tiny hole in the center or a mesh screen, it's an atomizer. If the ceramic is one solid, unbroken circle, it's a speaker. Okay, all right. I am looking at speakers. Definitely, I'm looking at speakers. Okay, I'm also seeing um, ceramic discs. I'm also seeing piezo ceramic discs of different sizes. Does that change the voltage or current requirement. When it comes to raw piezo ceramic discs, the physical size usually measured by the diameter of the metal plate, which is 12 millimeters, 20 millimeters, 27, 35, etc., definitely changes how they behave, but it doesn't break the safety rules for your ESP32. Okay, here is how size impacts your Rust project. The electrical impact capacitance. A piezoelectric, a piezo disc is essentially a capacitor made of ceramic. In physics, the larger the surface area, the higher the capacitance. Small discs have low capacitance. They are very easy for the ESP32 to drive. Larger discs have higher capacitance. The result, a larger disc requires a bit more current to charge and discharge the ceramic at high frequencies. While still safe for a GPIO pin, a very large disc, larger than 35 millimeters, might sound slightly muffled if driven directly because the ESP32 can't fill that large capacitor fast enough. The audio impact, resonant frequency. This is the most noticeable difference. Every disc has a natural frequency where it vibrates most efficiently and loudly. Smaller discs have a higher resonant frequency, which is 4K hertz to 6K hertz. They sound they sound thin and chirpy. Larger discs have a lower resonant frequency. Example 1.5K to 3K. They produce a deeper, richer tone, relatively speaking, and are generally much louder. Rust tip for the best volume, check so and so, so and so, so and so. Voltage requirements. The voltage requirement doesn't technically change. All of these discs will work at the ESP32's 3.3 volt. However, larger discs have more room to move. If you give a 12 millimeter disc 12 volts, it might reach its physical limit quickly. If you give a 35 millimeter disc 12 volts via a transistor, it'll be significantly louder than it was with a 3.3 volt because than it was at 3.3 volts because the larger ceramic surface can handle the larger flex caused by the huge voltage. Do I need to worry about voltage or max voltage and current when it comes to these discs? When it comes to the raw piezo discs, the sandy colored ones, your concerns about voltage and current are valid, but the danger, quote unquote, is different than what you would expect with a motor or a standard speaker. Here's a breakdown of what you need to worry about and what you don't. Max voltage. Can you pop them? Piezo discs are incredibly tough. Most are rated for 30 volts to 50 volts peak to peak. What does peak to peak mean? Peak to peak voltage. Peak to peak voltage is the total voltage measured from the lowest point to the highest point of an alternating current waveform. Oh, alternating current would go into the negatives, right? Uh, Representing the full vertical height. Though, okay, I need to see if there is like a negative voltage happening in my PWM signal. I haven't thought about that because we are generating a frequency, right? So I need to see if there's like a negative voltage happening, but okay, I get it. Peak to peak. So negative 30 to positive 30 or negative 50 to positive 50. With an ESP32, you are only providing 3.3 volts. You are nowhere near the physical limit of the ceramic. you cannot pop or fry the disc with an ESP32. The volume ceiling, because the ESP32 provides so little voltage, the disc won't be very loud. If if you eventually use a transistor to drive it with 12 volts, it'll be much louder but still perfectly safe. Max current. The ESP32 is the one at risk. As we discussed, the disc acts like a capacitor. The bigger the disk, the more current it asks for. At the exact moment the signal switches from low to high. From low to high, so it's constantly going to be having like current spikes. The worry, if you use a large disk at a very high frequency, the charging current might exceed the 20 to 40 milliamp limit of your ESP32 GPIO pin. The solution, this is why we use a current limiting resistor in series. The flyback voltage, the real danger. This is the one thing you do need to worry about. Piezoelectricity works both ways. Voltage equals voltage causes movement. This is how you make the sound, and movement causes voltage. This is how lighters and tap sensors work. If you drop your project, or if you drop your project, or if the disk vibrates violently and suddenly stops, it can generate a spike of high voltage and send it back into the ESP32 pin. This can kill your GPIO pin instantly. How to protect your ESP32 in Rust/hardware. To sleep soundly at night, um, add these two cheap components. So this is odd. This wasn't mentioned before. I feel like I need to do some research on piezoelectric speakers outside of LLMs um, before using the speaker, because sometimes it's saying that, there's no worry, you can directly power the thing, but sometimes then later on it's mentioning that, okay, you might have this issue though. Okay, series resistor. Put this between the GPIO pin and the piezo. It limits the inrush current, so the ESP32 doesn't struggle to charge the disk. Then Zener diode. If you're really worried, put a 3.3 volt Zener diode in parallel with the piezo. It will clamp any accidental high voltage spikes generated by the disk, preventing them from reaching the ESP32. Wait, how come you didn't mention the the back voltage, or what did you call it? The flyback voltage and the current spikes before. You said it's perfectly safe to power the raw disks using the ESP32. Or is it that it was mentioned? Okay, that is a fair pushback. I should have been more precise with the word safe. In the world of microcontrollers, safe is usually a scale. Compared to the magnetic puck, which will kill your pin in seconds, a piezo disc is considered safe because it doesn't have a low resistance coil that creates a massive sustained current draw. However, as you move from it works to engineering a reliable product, those hidden piezo behaviors like capacitance and flyback become important. Here's why I'm bringing them up now. Why it's safe. The simple answer, for 90% of hobbyist projects, you can plug a 20 millimeter to 27. I think it was brought up. I think this danger and stuff was brought up because I mentioned the size. Because I mentioned like the bigger sizes. So I think I need to stick with smaller sizes because I don't plan on making something that's supposed to be like super audible. I think I'll stick with 20 millimeters. Yeah, I think that's a decent size because they do go higher. They have 27, 35, 50. Um, I think I'll stick with 20 millimeters for now. And I think that would also be pretty cheap. I think that would also be much cheaper. Let me see what the size or 20 milliamps specifically, how much that would cost. So 27, okay. Then there's 12. Okay, this doesn't have any sales, or this specific thing doesn't have sales. 35, 35, 27, 27. What if I wanted just 10 pieces? Because they're giving me 20 pieces for a certain price, which is not bad. 20 pieces is definitely not bad for the price that they're charging. I just don't know if I need 20. I'm getting 20 though, so like I'm not complaining. Let's go for the other one. Let's see what what they are offering. Okay, 15. Okay, so there is, but this is more of a new shopper kind of deal. 20. Right, I can get the 20 for pretty cheap. All right, I think I'll go for 20 milliamps. Yeah, yeah. I think I'll go for the 20 milliamps. Milliamps? No, millimeter. Okay, why it's safe. For 90% of hobbyist projects, you can plug a 20 millimeter to 27 millimeter piezo. Just a second. Okay. A piezo disc directly into your ESP32. Play some beeps. Nothing will ever break. The capacitive spike is so fast that the silicone in the ESP32 can usually absorb it. The flyback voltage only happens if the disc is physically hit or flexed violently by an outside source. Okay. Dude, if that's the case, I wonder if hitting the disk with an outside source can actually power an LED. Like, I wonder if it can actually give around 3 volts. Okay, why I'm mentioning the risks now, the engineering answer. Since you asked about the different size, there you go. Okay. I asked about the different sizes and the max voltage slash current. You're digging deeper into the specs. The larger the disk, the less safe the direct connection becomes. Larger disk equals more storage. A 35 disk holds more electrical charge than a 12 disk. Switching that charge 2000 times a second, which is 2 kilohertz, puts a lot of stress on the GPIO's internal transistors. The tapping risk. If your project involves a piezo disc inside a handheld device, someone drops that device, the disc will flex on impact. Because of the piezoelectric effect, that flex turns into a high voltage spike. Without a resistor or a diode, the spike goes straight into your ESP32. The correct way to wire for so and so. Series resistor, parallel resistor. Summary. Am I contradicting myself? Is it safe to plug in and test right now? Yes, you won't see smoke. Is it safe for a permanent deployed project? No, not without those two resistors. Okay, that's fair. That's fair. Definitely. Okay. All right. So I have made progress on the piezo disc, and I'm gonna keep around. Let me look at my calculations. I'm gonna try and keep around $3 for this as well. I don't think it's gonna cost that much, but I'm gonna keep 3 USD for this. Um, I'm not entirely sure if I want to go for the speaker and amp module at this point because I do have a couple of other things that I need to look into. Though I kind of also do want a speaker and amp thing. I'm going to look into that. For now, I need to look into project cases. That's more important. I'm loving this dimming thing, dude. I don't know how well it's showing up on screen. Yeah, it's showing up well. It's showing up well on stream. I'm loving this dimming thing. This is great. This is awesome. And this works even with Markdown. So like with stuff like Markdown and Rust and Python and stuff like, specific cases where the text it tends to have like semantic meaning of some sort. There it highlights and dims in like a different way. And here with regular text, it's doing this. I'm sure if there's um, like if I do something here, okay, I was about to say, I'm sure if I do this, then like it creates a separation, but that's not happening. I have seen that being the case in another situation, but that situation was actually a markdown situation. So maybe I'm confusing the two here. Maybe that's just a markdown related behavior. Either way, I'm loving this dimming thing. This is great. Okay. All right. What else is okay? I do need to look into the moisture sensor, light sensor, temperature sensor, humidity sensor, and water level sensor, though all of these should be relatively simple to pick out. I know exactly what I'm looking for. I'm just going to order those. I'm not going to spend time looking too deep into them. Multiplexer, SPI multiplexer. I don't know if I'm going to go for this because I feel like that's going to, yeah, I don't think I need this for now. I don't think I need this for now because I don't have like that complex of a setup going on. In the future, if I ever need multiplexing, SPI multiplexing, then I'll see what to do. For now, though, I'll let that go. I do need the project cases, so I'm going to need to spend some money on this. I kind of want to buy different sizes and shapes, but more importantly, sizes, because they'll be for like different purposes. But yeah, dude. Um, I mean, now that I'm thinking about it, I have these other. No, no. Okay, I was about to say that now that I'm thinking about it, I have these other boxes that I can very easily modify for various purposes, but no, actually, I cannot because um, I'm trying to think of a reason for the because, but the real reason is that like my best guess is that for the other boxes, they are more storage containers, so I would be modifying them for my specific purpose. Whereas with these boxes are meant for actually I can Google the thing and show it on stream. Give me a second, real quick. Okay. Um, what am I looking up? DIY project case. DIY project case. Well, project case, project box, project enclosure. Yeah. Okay. So I kind of found examples of what I'm trying to show. I can bring it up now. So it's pretty much these kinds of boxes. ABS DIY plastic boxes. There's this as well. So like it has stuff to let you screw the box to something if need be. The outside itself also has screws, so you can close and open the thing. But yeah, that's kind of what I'm going for. That's what I'm looking for. I would also like something similar to this, like this glass kind of thing. I don't know if that's plexiglass or just plastic. I think it's just plastic. Yeah, I think it's just plastic. But yeah, this is kind of what I'm looking for, and I'm definitely looking for plastic. I'm not looking for like metal or aluminium or something like that because that's going to become expensive. What I was hoping for is to get just 3D printed boxes like this, and 3D printed specifically because I was hoping they would be cheaper. But I guess for project boxes, this is kind of like a standard. There's ABS and there was something else as well, IP something. I don't remember what exactly that was, but yeah. Okay, now give me a second. Give me a second here. Wait, what's going on here? There's someone teaching calculus on Twitch. That's amazing. That's awesome. Okay, this is verified accounts only. We can't do that. This is verified accounts only. Okay, let's try someone else. Okay, I found two here. This is okay. Can't do that. We can probably do this one. However, I'm not entirely sure this person is here. Are they here? No, it looks like there's like a whole automated thing going on. Okay, all right, we're gonna go here. Uh, we are going to a person named the Big Crybaby. I hope they don't have any settings that prevent raids from small streamers or raids in general. Okay, no, it just says that it's intended for mature audiences. Great, awesome. So that's gonna be it for today's stream. I need to finish this shopping list so I can actually place the orders because that's gonna take some time as well. But yeah, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.